Indirect reasoning is just like it sounds. It's the opposite, basically, of direct reasoning or deductive reasoning. In direct reasoning or deductive reasoning, you go from the hypothesis to the conclusion in a direct manner, using logical arguments. Indirect reasoning, you do basically the opposite. You start off in the complete opposite direction, but it still ends up coming around and reaching the same conclusion. What I mean by that is, in direct reasoning, you start with a hypothesis and then go through and explain what that means. With indirect reasoning, you start with the hypothesis and the negation, the opposite of the conclusion, and then go through using logical arguments until you reach a contradiction. So with indirect reasoning, you start with the hypothesis as true and the conclusion as false, basically. You take the opposite of the conclusion and the hypothesis, use those until you reach a conclusion. So let's look at this example here of how we could do indirect reasoning. If a triangle has a right angle, then the other two angles are acute. So you start with assuming the hypothesis is true, so it does have a right angle, and you take the opposite of the conclusion. So that would mean it has one right angle. I'm not going to do a formal proof, we're just going to kind of talk through this real quick. It has one right angle, and we negate the conclusion. We take the opposite of it, basically. So then the other two angles are acute. The negation would be the other two angles are not acute. So that could just mean that there's one of them could be acute, but the other one is not, at least. So that means there's one angle that's not acute. So that means there's one angle that is greater than 90 degrees, or equal to 90 degrees. And then one angle, it could be anything. But if that's the case, we have a 90-degree angle, and then something that's at least 90 degrees, so 90 degrees or more, and then we have an angle that's something, but it has to be more than 0. So it has to be at least, and it could be a fraction, but we'll say at least 1. But then if you add up all of those angles, we get 181 at least. And we know that the angles of a triangle add to be 180 degrees, so this cannot be so that means our conditional statement's true. It can't be that one of the angles is more than or equal to 90, so they have to both be acute. So here's some vocab. Parallel lines are coplanar lines that do not intersect, like these two lines right here, BC and AD. Skew lines also do not intersect, but they are non-coplanar, meaning they're not in the same plane. So that would be like BC and EF. They don't intersect because they're in different planes. BC and EF are skew, or you could say AD and EF. BC and AD are parallel. And when we have two lines cut by a transversal, the transversal is just the line that intersects the other two lines. It forms 8 angles. There are alternate interior angles. The pair of angles, angle 3 and angle 6. Those are alternate interior. And angle 4 and 5 are also alternate interior. They are interior because they're between the two lines, but they're on alternate sides of the transversal. Similarly, alternate exterior, that to be outside the two lines, and on alternate sides of the transversal, so that would be angles 1 and 8. And also angle 2 and angle 7. Corresponding angles are just in the same corresponding spots. So like angles 1 and 5, they're both in the bottom left if you just look at each intersection separately. Also angle 2 and angle 6. Angle 3 and angle 7. And angle 4 and angle 8. Same side interior. Interior between the parallel lines. Same side like angles 4 and 6. Or 3 and 5. Same side exterior, just like it sounds. Same side of the transversal, but outside the two lines. Like angle 1 and 7. Or angle 2 and 8. If the two lines, M and L, if they're parallel, if those lines are parallel, then alternate interior angles are congruent, alternate exterior angles are congruent, corresponding angles are congruent, same side interior or same side exterior are supplementary. They would add to 180. That's if the lines are parallel. Also, we could use those statements in reverse. They are if and only if statements. If same side interior or same side exterior are supplementary, the lines would be parallel. We could prove lines parallel that way. Or if we had alternate interior, alternate exterior, or corresponding angles congruent, the lines would be parallel. So we know if they're parallel, we get all of these, and also backwards, if they're congruent or supplementary, then the lines are parallel. So let's use that to prove that ABCD is a parallelogram. So the first thing we're going to do is extend the lines. So we have two lines cut by a transversal. Since it's a parallelogram, we know that opposite sides are parallel, so BC is parallel to, well, we're trying to prove it's a parallelogram. So we need to start with the angles. So we need to show that BC is parallel to AD. And looking at these angles, we do have angle BAD and angle ABC are supplementary. And we know that just by looking. 120 plus 60 is 180. So they are supplementary. They are also same side interior. So since these same side interiors are supplementary, BC and AD are parallel because same side interiors are supplementary. We could do the same thing down here. Angle BAD plus angle ADC those are supplementary, they add to 180. So that means BA is parallel to CD because same side interior angles are supplementary again. But now we know that opposite sides are parallel, so it is a parallelogram. Next, we'll talk about the parallel postulate, which states if we are given a line L and a point that's not on the line P, there is only one line that can go through that point that would be parallel to line L. There's only one line that goes through that's parallel. Now, the parallel postulate's a little bit interesting because it seems like you should be able to prove that, but for hundreds of years, no one's been able to. That's why it's called a postulate instead of a theorem. Theorems can be proven and have been proven, postulates cannot, but they are accepted to be true. Here's the angle sum theorem that the three angles of a triangle add to 180. I used that in an example earlier. The exterior angle theorem. We've done something like this before where we said that the exterior angle has to be bigger than either of the other two, but it's actually true that the exterior angle is equal to the sum of the other two angles. Now there's some more congruence theorems to prove triangles are congruent. There's angle, side that we can add on to our side, angle, side, angle, side, all of those. We now have angle, side. That would be enough information to prove they are congruent triangles. Also, if we have the hypotenuse and an angle, they're congruent. But really that's the same as angle, side. It's just our first angle is 90 degrees. We have the angle bisector theorem, which states if you have an angle bisector, any point on the angle bisector is equidistant, the same distance from the sides of the angle. And distance always has to be perpendicular to the line that we're measuring from. And if you think about this theorem a little bit, it's an angle bisector, so the angles are congruent. We measure distance with the right angle. And this length AP is equal to itself by the reflexive property, so we do have either angle, side or hypotenuse angle, since it is a right triangle, which would prove that the triangles are congruent, triangle BAP and CAP, and since the triangles are congruent, BP is equal to CP, because those are corresponding parts. So that would be how you would go through the proof of the angle bisector theorem.